Hi, hello, have a nice time. Good day to all of you. We are discussing the most important chapter of 11th class, structure of atom. On this chapter only, we go with other chapters because the knowledge of this chapter is very important. This chapter we learn once again in 10th class, not in chemistry, in physics. Okay, so there once again all these uh, de Broglie, Schrodinger, all we discuss once again under the what? Physics area. Okay, right. So let us start discussion of questions or the numericals on the chapter structure of atom. So, my dear students, I welcome you all for today's session on discussion on structure of atom. Okay, right. Calculate the wavelength, frequency, and wave number of light wave whose period is 2 into 10 to the power minus 10 second. Right. Hmm. Period is given. What is frequency? Frequency equal to 1 by period. This I told in the structure of atom under the topic electromagnetic radiation. And this all I think you might have heard from 10th class knowledge in the physics also. You what is the frequency, wavelength, sound waves, light waves, all those. Okay. So frequency equal to 1 by period. So 1 by period is given. So if you simplify, answer is 5 into 10 to the power 9. If you take second here to the numerator, it is per second. Okay, right. What is wavelength? Wavelength equal to c by frequency, c by nu. So c is the velocity of light, speed of light. We know it is a constant value. Nu just now we have calculated. Simplify 6 into 10 to the power minus 2 meter because per second gets cancels and meter is the what unit for the this wavelength. Now wave number is the reciprocal of wavelength. So nu bar equal to 1 by lambda. So 1 by lambda after the simplification 16.66 per meter is the wave number for this wave. Okay, right. These are all basic calculations. What is the number of photons of light with wavelength 400 picometers which provide 1 joule of energy? Hmm. Wavelength is given in the picometers. Okay. So wavelength equal to what? Wavelength equal to 400 picometers. Convert it into what? Meters. Why meters? Because we have to take the speed of light in the meters unit. No, that's why let us convert picometer to the meter by multiplying the 4000 by 10 to the power minus 12. That is called converting factor for the picometer to the meter. That gives you 4 into 10 to the power minus 9 meter. This is the wavelength. Okay. H is what? Planck's constant we know, and C is the speed of light. So now we will go for the energy of photon equal to h nu. So nu equal to what? Nu equal to c by lambda. So therefore E equal to hc by lambda. H is given, c is given, lambda. Just you substitute and simplify. Answer is 4.969 into 10 to the power minus 17 joules. Okay, right. Now, what is the number of photons in 1 joule of energy? Okay, see, this is the energy of the one photon, right? So 4.969 into 10 to the power minus 17 joules means one photon. Now 1 joule means how many photons? So 1 into 1 by 4.969 to 10 to the power minus 17 that I have taken here. So after simplification, you will get 2.012 into 10 to the power 20, 10 to the power 16 photons are there in the 1 joules of energy. Okay, right. A photon of wavelength 4 into 10 to the power minus 7 meter strikes on metal surface. The work function of the metal being 2.13 electron volts. Calculate number 1, the energy of the photon. Number 2, the kinetic energy of the emission or emitted radiation. Third is what? The velocity of the photoelectron. Given that 1 electron volt equal to 1.6020 into 10 to the power minus 19 joules. Okay, right. This problem depends upon the photoelectric effect. Okay, right. Now what you'll do, you'll go to the first part, that is the energy of the photon. Energy of the photon equal to h nu. Nu equal to c by lambda. Therefore, E equal to c by lambda. Planck's constant, speed of light by lambda is given. How much lambda? How much lambda? 4 into 10 to the power minus 7 meters. Already it is in the meters. Okay, no problem. So after the simplification, we get 4.97 into 10 to the power minus 19 joules is the energy of the photon. Okay, right. It is in the joules. Now let us convert into the electronic volt. Okay. So 1.6020 into 10 to the power minus 19 joules means 1 electron volt. Now this many joules equal to how many electron volt? It is equal to 1 by 1.602 into 10 to the power minus 19 into 4.97 into 10 to the power minus 19 joules. That gives you 3.1 electron volt. So energy equal to what? 4.97 into 10 to the power minus 19 joules, or in terms of electronic volts, it is equal to 3.1 electronic volts. Okay, right. Now we'll calculate what? Kinetic energy of the emitted radiation or the emission. For this, we have to use the knowledge of photoelectric effect I told. So, energy of incident photon h nu is equal to work function h nu naught plus kinetic energy of emitted electron. That is nothing but what? Half mv square. Correct? So, please recall, we gave, or I gave an equation h nu equal to h nu naught plus half mu square, or the kinetic energy. Right? Therefore, now kinetic energy equal to what? H nu minus H nu naught. Okay, so therefore, kinetic energy equal to what? This is H nu. This is equal to what? H nu minus work function is what? H nu naught. What is H nu? Just now we have calculated H nu. Okay, what is H nu naught? Work function is given here. So 3.1 minus 2.13, both in electronic volt, simple minus gives you 0.97 electron volt. This is the kinetic energy of the emitted radiation. Now, let us calculate the velocity of photoelectron. What is the kinetic energy formula? Kinetic energy equal to half mu square, or after the cross multiplication, 2 into kinetic energy equal to what? Mu square, or v square equal to what? 2 into kinetic energy by m. Okay, that I have taken here. So v square equal to what? 2 into kinetic energy by m. So v square equal to 2 into kinetic energy. What is kinetic energy? 0.97 electronic volt. So please convert it into the joules. Why joules? Because we have to take the mass of electron in the kilogram. That's why please convert it. So 0.97 electron volt. So 1 electron volt equal to this much joules. Then 0.97 electron equal to how much? 0.97 into 1.6020 into 10 to the power minus 19 joules that I have taken here. Okay, 2 into what? Kinetic energy in terms of what? In terms of joules. Okay, this is joules. Now, what is 1 joule equal to 1 joule equal to 1 kilogram meter square per second square. This is the kinetic factor we learnt in the chemistry also, as well as from the physics. Therefore, it is 2 into 0.97 1.602 into 10 to the power minus 19 joules or kilogram meter square per second square. Why kilogram? Because mass of the electron is in the kilogram. So we have to go for the similar units. Therefore, in this step, 0.97 into this is for the electronic volt. Okay, sorry, electronic volt into joules converted. So this is in joules. That is equal to what? 0.97 1.602 into 10 to the power minus 19 in terms of kilogram meter square per second square, because once again I am repeating 1 joule equal to 1 kilogram meter square per second square. Using that factor, I have done this one. Okay, right. So kg gets cancels here. So after simplification, v square equal to 0.34 into 10 to the power 12 meter square per second square. Now what is v equal to? V equal to square root of this value. Okay, so when you simplify by any method, log or any other method in mathematics, we get answer 5.83 into 10 to the power 15 in terms of scientific notation. Meter per second is the frequency. Okay, right. Now, next, electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize sodium atom. Calculate the ionization energy of sodium in kilojoules per mole. Okay. So he has given the wavelength to ionize. How much? 242 nanometer. So 242 nanometer equal to what? This much meter by multiplying with 10 to the power minus 9 converting factor. Please refer first chapter, nanometer, picometer, angstrom unit, yocto, all those we have studied in the first chapter itself. So therefore, 242 nanometer equal to what? 242 into 10 to the power minus 9 meters. This is lambda given. C constant, H constant. So equal to what? Hc by lambda, Hc by lambda. That gives you energy equal to 0.0821 into 10 to the power minus 17 joules. Okay, right. Now he has told to calculate the ionization energy of in terms of kilojoules per mole. This is only in 1 joule. Okay, so 1000 joules equal to 1 kilojoule. Right. So this much joules equal to what? So this much into by 1000. That is in the kilojoules. So this I have taken here. This by this equal to in kilojoules. Okay, right. Now we have made it into kilojoules by dividing by 1000. Now, for per mole you have to calculate. No. So 1 mole equal to what? Those many electrons. Those electrons are only coming as emissions in the form of wavelength. No. So those many wavelengths. Okay, that is 6.022 into 10 to the power 23 wavelengths in terms of electrons they are coming out. Okay, right. So for one energy, this much is the kilojoules. So for these many, 1 mole, okay, multiply by the Avogadro number. So after multiplying this with kilojoules with the mole concept of mole number, Avogadro number, so ultimately what you get? It is called ionization energy per mole, which is equal to 494 kilojoules per mole. So in this way they calculate and give in the form of table in the log table. Okay. So I think we have studied some important numericals, and in the coming session we discuss a few more. Till then, keep practicing and don't lose the touch. Thank you, my dear students.